Hey guys, in this video tutorial we're going to take an in-depth look at raw transactions in Qtum and how they work, and we're actually going to go into a step-by-step tutorial on how to actually create a raw transaction that will call a contract. So we're first going to look at what the raw transactions are. We're going to compare to what a raw transaction looks like in Bitcoin versus Qtum, and talk about how Qtum has the ability to make contract calls similar to the way that you would in Ethereum, but Ethereum has a completely different model than Qtum does because of the fact that Qtum is built on the Bitcoin UTXO model. Alright, so now we're going to take an in-depth look at the different types of transactions, namely the Ethereum, the Bitcoin, and the Qtum one. The Ethereum being because Ethereum was obviously the first blockchain to do contract calls. Their whole thing is being a blockchain to build applications on top of, and the smart contracts are a big part of that. Bitcoin, obviously everybody knows Bitcoin is just the transaction of funds and just the transferring of funds from one address to the other. Qtum is a mix of both in the sense that it uses the Bitcoin UTXO transaction model, but it has an abstraction layer to allow for contract calls on an EVM machine as well as the way that Ethereum works, essentially. So we're going to look at Ethereum's first. I'm going to link this article on the description of the Medium post. But it's a really good in-depth article that goes into what the transactions in Ethereum are like and what they mean. It goes into what the actual hash data is and what it translates to, and what each section means. We're not going to go too in-depth on this because it's Ethereum, and we're going to do essentially this but for Qtum in a second. But we're going to take a look at this, which is the kind of human-readable version of the raw transaction on Ethereum. It's very simple. It has the nonce, it has the gas price, it has the gas limit, the to address, the value, and the data of the call. So a lot of these things are going to translate into what we're going to look at in this article, but it's very specific to making a contract call. It's very straightforward in terms of what it's supposed to be doing. Now compare that to the Bitcoin one, which we'll see right here. Again, this article, it's a very in-depth tutorial into Bitcoin raw transactions. I will link it for those of you interested. In fact, very cool about this one, it has a lot of little tutorials on how to build raw transactions and how to send simple transactions. It uses the Bitcoin CLI. However, the Qtum CLI, the QCLI, uses the exact same calls. So you could follow this almost to the teeth on Qtum as well. The difference being that the transactions will look a little bit different. So here we see a Bitcoin transaction right here, and so you can already see that it's very different from the Ethereum one. There's a transaction ID. This is for the UTXO. There's the hash, the size, the ID, the VINs, and the vout. So this is the output versus the input. We can start to see here, this will be what will be transferred, what will be returned, the address that the UTXO will return to. So there's a lot going into it. We'll go into more in depth of what each of these mean in terms of Qtum, because of the fact that the Qtum transaction actually looks extremely similar to that. But yeah, so now we can see that there's a big difference between the Bitcoin one and the Ethereum one, and Qtum is somewhere in the middle. So we're going to look at that now. Alright, so now that we've seen kind of the basic layout of an Ethereum raw transaction and the basic layout of a Bitcoin raw transaction, where the Ethereum one is very based off making contract calls and the Bitcoin one based off the UTXO model to just transfer funds, we're not going to look at the Qtum one, and we're actually going to build a very basic one just to show you how it kind of works. So to do that, first let's go to qmix.blockchainspaceman.com. This because we're actually going to be using this later on in the tutorial, but right here on the help tab we'll give you the Docker command that you'll need to run a QCLI on your computer. So as long as you have Docker on your computer, you can run this command right here. Docker run ends in Spaceman Holdings -Qtum portal dev. So copy paste that into your terminal and run it. And once you have the blockchain running, you can just do this command right here. Docker exec tac it -bin-sh, and this will just run the QCLI on constant flow on your terminal. So we have that here, and once you're there, you can just type in QCLI help, and this will give you all the different commands that you can use here. Definitely play around with this, it's super interesting. You can play around with wallets, you can play around with blockchain information itself, with mining. It's really good to get acquainted with Qtum and Qtum developing. And for our purposes, really importantly, it has a lot of things that we can do with raw transactions. So you can convert from hex addresses, decode scripts, sign transactions, send them, and interact with your little local network. So let's actually create a raw transaction right now. So if you do QCLI create raw transaction, it will give you the commands that you can use. And here you can already start to see the same kind of layout that we had with Bitcoin. We have the transaction ID, the VOUTs. This will create the VIN. What's extra here that you can't do on Bitcoin, obviously, is the contract aspect of it. And here you can start to see the similarities with the Ethereum raw transaction, where you have the address and you have the data that you want to send to the smart contracts to execute the command, the amount, the gas limit, and the gas price. So here you can already see how they start to mix. This is what's similar to Ethereum's raw transactions, and this is kind of what's similar to the Bitcoin raw transactions. All right, so here you can have examples. So let's create a super basic one. And this is not going to work right now because of the fact that you actually need to put in the correct information. So here, the transaction ID, that has to be the transaction ID of a unspent transaction, a UTXO, with enough funds to complete the transaction. And I'll show you how to do that right now. And that will be replaced. You'll replace that in my ID. We'll leave VOUT as 0. And the address, you just need to change that to an address for which to return the remainder of the quantum that you're, in this case, sending. This is just a simple send transaction. So let's do that right now. QCLI list unspent. This will give you the list of unspent transactions. So we can use this ID right here. Transaction ID. You can set it to a local variable to make things a lot easier. And we'll actually also copy the address. We'll do return address. And finally, remember this right here, 200,000, no, it's 20,000. This will be relevant for us to be able to execute the command. So we'll do create the transaction. We're not going to do 0.01. We're actually going to do 9999. And we're going to change my ID here to $ transaction ID. And I forgot to change the address to $ return address. All right, so this will actually create a raw transaction. We're going to take a look at it and explain what we came up with. So this is the actual raw transaction, but this is the hex version of the raw transaction. So what you can do is QCLI decode raw transaction, put in the hex format of the transaction, and this will give you the human readable version. So as you see, it's almost identical to what we saw in Bitcoin, the transaction ID. This is the transaction ID of the UTXO. Actually, no, this is the transaction ID of the UTXO. This is the transaction ID of this actual transaction. We have information about just kind of like the system as a whole. This is the information of what we're inputting for the transaction, so the UTXO for which the funds are going to be taken from, and which VOUT we're actually looking at. And then we have script sig. So script sig, what this is the actual script code that's going to be executed once the transaction is broadcast. Currently it's empty. This is filled in once it's signed. But this will have kind of opcode information, and in the case of contract calling, actually that will be in the VOUTs, but this is basically what the script code will be executing once it's actually filled in. Then we have the VOUT, so this is the output of the transaction. This is the amount that's going to be returned. This is the ID of this VOUT. Then we have, as I said, the script code. So this is for the public, and this is going to be assembly and hex. So hex is just the hex version of the assembly code. And here we see some operation codes, and then some hex data. And this is basically giving the instruction to the script that's going to be executing this transaction, saying, okay, this is what we want to do. And this is the address that we're going to be sending those funds to. So to complete this transaction, we actually just need to sign it. So QCLI sign raw transaction. And we use the same hex code that we used before. And this will output a different hex code. And this is the hex code of the actual signed transaction. So we can do it again, decode raw transaction. And now we see that it's the exact same as before, but the assembly and hex of the vin has been filled in. And this is basically giving the instructions on what to do once this is broadcast and how to confirm that this is in fact a valid transaction that has been signed, and this is the information to prove that it has a valid signature that can be broadcast to the network. So now this is a complete transaction. As you can see, super similar to the one on Bitcoin, and it can be broadcast. So now we can do QCLI send raw transaction, and we paste in the same hex, and we get a transaction ID back, basically saying that this was a success. We've successfully broadcast this transaction to the network. In this case, our little local reg test network. To confirm it, you would just need to generate one block. And there you go. So we've successfully created a raw transaction on Qtum. We've kind of went through what it's all about, and we've broadcasted. So the next step now is actually to show you what the raw transaction on Qtum would be if you're making a contract call, which is what makes Qtum unique in the fact that it's using the same model as Bitcoin, except that Bitcoin can't do contract calls. So we'll do that next. Alright, so now that we've seen that, we're going to look at now how the Qtum raw transaction differs from the Bitcoin raw transaction, which so far we've seen is extremely similar. And in what way it's actually similar to an Ethereum raw transaction, in the sense that it can actually call on contracts and make those contract calls that make Qtum. So what we're going to do is actually create a raw transaction. We're going to broadcast it and deploy it on our little local network. We're going to interact with it such that we're going to get a transaction call which interacts with it, and we're going to look at it. We're going to look at what each component is and what it means, and then we're actually going to build our own raw transaction from scratch in order to interact with that contract. So let's do that. First, we're going to have to go to Qmix once again. Go to the File tab over here. You're going to create a new file. I already created one. I called it test.sol. The contract that I'm going to use is just one that I found in the Solidity docs. I'm going to again link this on the article itself, but I just did a super simple storage contract right here. All it does is set a variable, and you can get that variable. So just copy and paste this into your Qmix editor, save that. Make sure it compiles. There should be no problem in compilation. Go to the Run tab. All of this is going to be autofilled. This means that you're connected to your local network. This is the UTXO address. All of this is autofilled, so don't even worry about it. And we're going to deploy that contract. All right, so once it's deployed, we should get an address, so 976, etc. We're going to copy that. It'll be useful for the coming steps. So you can actually confirm that it's on list contract. We can confirm that it's been deployed on our network. 976D3, we can see right here that it is in fact deployed and on our network. So let's just set this to a variable called ADDR address. This is going to be useful for later on. Alright, so let's go back to Qmix. We're actually going to set, let's just say to 7. Let's set the variable. And we get a transaction ID out of that. Let's just make sure that we did. Yes, it's 7. Alright, so let's copy and paste this transaction ID. Let's go back to QCLI. QCLI get transaction. Paste that transaction ID. This will give us some more information about the transaction itself. But more importantly, we're going to get the hex of the raw transaction. So we're going to do what we were doing before. QCLI decode raw transaction. Put in that hex code, and we get the raw transaction. So as you can see, it's super similar to what it was before, but there's an extra component here, and there's another V out right here. This right here is the actual contract call. No, sorry. This right here is the actual contract call. This right here is extremely similar, if not identical, to what we had before. Just a very simple transaction. This is the transaction ID of the VIN. This is the assembly and the hex code of once we've signed the transaction, how to verify that it is in fact signed and correct. And then just the return off the UTXO, the address to return it to, and the commands to execute that transaction. And then finally, the actual contract call aspect of this transaction is right here. So this is where we differ from Bitcoin, in the sense that Bitcoin doesn't have this at all. And this is similar to Ethereum because of the fact that we have all the information that we would need to make a contract call, similar to the way that the Ethereum raw transaction does as well. So this assembly code right here is in fact actually the call that we just did on our contract. So let's decipher this a little bit just so you can kind of understand what's going on. This 4 right here is the VM version that we're going to be using, for meaning the Ethereum virtual machine. For this 40,000 right here, or 400,000, is the gas price. If we go to back to QMix, we'll see that right here. That's the value that we set there. If we change this, that would change on the transaction we just did. Then this is 40, that's just the gas price in Satoshi. And this right here, that's the actual contract call. This is kind of the coded name of the contract, so that this would be in this case set. And this is the actual value. So as you can see, it ends in a 7. We just set it to 7. So this is set, call the set command and use 7 as our input. And this right here is the actual address of the contract. And then this is the opcode opcall, meaning we're doing a contract call. And this right here is just the hex version of that information. All right. So now you understand kind of the basics of raw transactions and how the raw transactions on Qtum differ from Bitcoin and Ethereum. And when you actually do a raw transaction that makes a contract call, what that actually means and how to interpret it a little bit. So what we're going to do now is actually create our very own raw transaction in order to set the number on our smart contract to 5. So let's do that right now. Alright, so now let's actually build that raw transaction. So what are we going to do? We're going to create a raw transaction that will actually call the contract that we have running on our little local network. And so what we're going to try to do is basically duplicate this transaction right here. So this first part of the transaction is exactly the same as the transaction that we created earlier on in the video, where we have the input, which is just the unspent transaction ID, and that's pretty much it. And then the output will just be the address which we're sending back the money to, and the amount. The only additional thing that we need to do is actually add the contract information, so the contract call. So if we go to QCI create raw transaction, sorry. We have the information that you would need to create all kinds of different raw transactions. In this case, we just need the address and the amount, as we did before, the unspent transaction, and the contract information. So as you can see here, we need the contract address, we need the data amount that we're sending to that contract. In this case, it'll be 0, the gas limit, and the gas price. So the thing that we want to take care of is data. So how do you get this data? It says here it's the hex data to add to the call output. Really not that informative right here, but what this means is what are we trying to get from the contract, or how are we interacting with it? And that information is right here. As we had mentioned before, this is all kinds of information about what we're actually doing with the contract. This is the VM version, this is the gas price and the gas limit. And then right here, this is the actual method call with the variable, with the actual input that we're using. So this is the method call. This is the equivalent of the set that we have right here. And what we're inputting into that method is 7, or at least what we did originally. And then this is a contract address, and this is the opcode that tells the script to execute this as a contract call. So this right here is actually what we need. Even though it says hex and this is assembly, this is the hex version of the call, and then this is just the completed hex call with all the other information. But as you can, like, from here see, we already provide all this information. The only information that we're missing is this right here. So this is the actual data that we need. So let's set these all in different variables. So let's do data equal to, and we'll do lost it right here. And let's change this to 5, because we don't want it to be 7 anymore, we want it to be 5. So this will actually prove that we've changed it. And I think I already did a little test one, so just to make sure that we are on the same page, let's set this to 7, make sure that we're getting 7. Alright, perfect. So we're actually going to change that to 5. So then we get the contract address. We're going to set that to address. I know I already did this before, but just for good measure. And what else do we need? We need the unspent transaction ID and the return address and the address of that where we're returning the money. So let's do that, getting the list unspent. And just to go through the whole process, what we're going to do is set those two. I already have the call ready to go because it is kind of long. I don't want to type it out. I will put this in the article for those of you that are following along and want to just kind of copy and paste it into it. Here you can see the actual variables that I'm setting right now, such as the address and data. That way you can just kind of change it without having to change the call itself. This is just ready to go and copy and paste. But so let's set those things. Let's set the unspent transaction ID and the return address. And we're going to create that transaction, sign it, and broadcast it to the network. And then we're going to go through what each of those things look like a little bit more in depth. So let's go QCLI list unspent. Let's use this right here. So ID equals the unspent transaction. We're going to use this address right here. We're going to do return address equals this right here. Alright, so now we can just use this right here to create a new raw transaction. So this is a raw transaction that hasn't been signed, so let's sign it. Sign raw transaction. Alright, we get a signed transaction here. We get the hex address of that signed transaction, and let's actually send that transaction. So QCLI send raw transaction. And we get the transaction ID of that broadcast. Alright, so just for good measure now, let's do QCLI generate 1. We're going to generate a block so it confirms that transaction, and that should actually be completely broadcasted right now. And let's go back to our contract, and as you see last time we did it was 7, and now if we get this it should be 5. And yep, as you can see we have changed successfully the variable inside of our contract to 5. So what does these things mean? Right here, when we originally created our transaction, if we decode it, you can see that it will be very similar to what we were trying to achieve in duplicating the transaction. And it has exactly what we wanted here. It has the contract call as we wanted it, except setting it to 5 instead of 7. The only thing missing from the original one was this right here, which is filled in once you sign it, which is this transaction, this one right here. And this will be basically the exact same transaction that we originally started off with, which we can actually confirm by doing these steps again. Get transaction. As you can see from this one, which is the one we broadcasted from QMix, versus this one, which is the one we actually built ourselves, it is basically the exact same, except for the little changes that obviously need to be there, such as the different assembly and hex over here versus the transaction ID that we used. But we effectively just created our very own raw transaction from scratch to call to the contract that we've broadcasted to our network, and from the fact that we got 5 back shows that we were completely successful in it. So congratulations, you've just built a raw transaction from scratch and actually were able to make a contract call with it.